that probably take her.
Yo, what is up? We are back with another video, Unit 10 test review. I know it came quickly, but it's for the best. We get it over with. Let's do well on this one, man. Unit 9 was a little mixed in scores, but you know what? Let's do really well on this one, okay? Check the video out. I hope it helps. Let's get started. So today we got Unit 10 test review. Let me zoom in so I can get more space. All right. Let's start right here with this graph for number 1. Graphing this, guys, not bad at all. All right. What I want to do is first identify a vertex. All right. Remember your vertex is H and K. All right. So H right here is going to be plus 4. So we go to the right 4. And then we have plus 3. So I go up 3. And there's our vertex. All right. So that vertex is going to be 4, 3. Now, notice this negative out front. That negative out front tells us this thing is going to open down. All right. And the next thing we got to identify is the slope. Well, there's an invisible 1 right there that implied 1. So the slope is going to be, remember, slope is rise over run. So in this case, it's 1 or 1 over 1. So I'm going to go down 1 and over 1. All right, to make this graph right here. All right, no calculator needed. So down 1 over 1. Keep going. Down 1 over 1. All right, so I'm going to go ahead and sketch this up. So now, guys, we want to just extend this thing out. All right, so there's your graph. All right, make sure on the graph, on the test, man, you're actually graphing points and using them. All right, don't just throw some crap on there, man. It won't work. Okay, it won't work. So now, anyway, man, let's answer some questions now that we have the graph. Okay. So does it open up or down? Well, obviously, guys, it opens down. All right, so we're gonna put down the vertex. We already discussed the vertex, which was 4, 3. All right, remember the vertex is a point, guys. All right, 4, 3. Transformation, we have right 4. Right 4 units, up 3 units, and then reflect across the x-axis. All right, x-axis. The intercept, we have this intercept right here, 1, 0. And we also have this intercept right here, 7, 0. And then we have, those are the x-intercepts, by the way. Then we have the y-intercept. I'm using another color for that right there. -0, 1. I'm excuse me, 0, -1. That's our y-intercept. All right, y, x, and x. All right. Now, the zeros, guys, the x-intercepts are the zeros. So x equals 1 and x equals 7. And then we have the intervals right here, the intervals of increase and decrease. Well, remember, you always use your vertex, the middle of your vertex right here is 4. We got negative infinity and positive infinity all the way over here. So when you trace the line from left to right, remember you look at the graph from left to right. All right, when I trace the graph right, there's an increase. So I have an increase from the point negative infinity to 4. And then I have a decrease from 4 to positive infinity. All right, and I say decrease because look how the line's going down to the right. All right, let's look at number 2. So for this problem, number 2 here. Let's see here. All right. So remember your vertex is HK. Notice you have an H right here. All right, you do not have a K. So that means we're not going to go up or down. So here's what we got. We have left 6, but there's no K. Because there's no K, we don't go up or down. That's my vertex. All right, there's nothing. There's no +3 or -3, so I can't go up or down, right? I stay right there at 0. So my vertex is going to be -6, 0. Now my slope is going to be, remember, rise over run. So in this case, we have 2 right here. All right, so it's going to be 2 over 1. So I go up 2 over 1, up 2 over 1. All right, like that. All right. So now we are going to connect our dots. So we have that and that. All right. So now I have my vertex. Let's see. Oops, didn't mean to do that. Let's make it a little smaller real quick. Oh man, I did it again. All right, so let's answer some questions. This opens up. Oh man, I'm tripping. All right, guys, there we go. And then we have the vertex of -6, 0. Transformations will be left 6 and vertical stretch.
That probably take
By 1. By 2. Alright. And then we have intercepts. We only have this intercept right there, -6. That's our only x-intercept, excuse me, -6, 0. For our y-intercept, we have, let's see, if I made that 0, if I made x 0, that'll be 0 plus 6 is 6. And then 6 times 2 is 12. So 0, 12. My y-intercept will be 0, 12. All right, you can also just look at your calculator. You put that function there right there. And then look where x is 0. That'll give you your y value. All right. Continuing on. My 0, I have just one 0. X equals -6. And then my intervals of increase and decrease. Well, we have negative infinity out here. My x value, -6. And positive infinity. From left to right, this would be a decrease. So negative infinity to -6 would be my decrease. I'm sorry, negative infinity. Why did I write -6? I must be really tired. To -6. I keep doing that. Alright, negative infinity to -6. There we go. And then that means my increase is going to be from positive infinity. I'm sorry. I keep doing it. It's going to be from -6 to positive infinity. Alright, there we go. That's our interval increase and decrease. Sorry about that. Struggling today, but please bear with me. I appreciate it. Now, this next problem. Let's go ahead and do this one. Alright. So, we got quite a few things going on with this one right here. Let me make it a little bigger. Alright. So my vertex is going to be right 1 up 4. So right 1 up 4. Alright, so that's 1, 4. Alright, and then my slope is 1/2, or in this case it's going to open down, but it's -1 right 2 or left 2. So down 1, left and right 2, down 1, over 2, like that. Remember, your negative tells you this thing is going to open down. Okay, so let's see here. Where is my, right there. So we have that thing right there. And, ooh, that was off. I'm gonna do that one again, guys. That looks a little better. Now, I want to look at very quickly this in the calculator. So I'm going to put this in the calculator real quick because I want to find my y-intercept using that. Just because I want to do it. Alright, so give me a second. So in case you don't remember how to do it, remember how you put this in. You're going to go negative 1/2. Alright, then we have math. We want to move over to NUM. And there's our absolute value function right there. And we have x minus 1 because it went right 1. And then outside the parentheses, we have plus 4. Like that. So now I graph this thing. Alright. For my intercept, I can see this x-intercept right there. So 1, 2, 3, 4, 5, 6, 7. That's -7. And this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can see that one. Alright. And I'm also just going to show you how to check it on your table. The ones we can see. See 9, 0. Right? For one x-intercept. Oh, there's my y-intercept right there, 0, 3.5. Alright, 0, 3.5 for my y-intercept. And -7, 0 for my other x-intercept. Alright. Alright, anyway, I just want to answer these questions. This thing opens down. Ooh, that's bad. Okay, there we go. This thing opens down. Alright, the vertex was 1, 4. The transformations were right 1, up 4, reflect x, and vertical compression or shrink. You can say compression or shrink by half. Alright. Now my intercepts. We said that the x-intercepts were -7, 0, 9, 0, and the y-intercept was 0, 3.5. Alright, we got all that from the calculator a second ago. If you don't remember, just rewind a little bit. My zeros are the x-intercept, so x equals -7 and x equals 9. And then my intervals of increase and decrease. Way out here is -infinity. My x value right here is 1 and positive infinity. Alright, too many times I've seen people do this. They use y right here. I don't know why you use the y value, guys. It's always the x value of the vertex or h. So -infinity to 1 is an increase, and then 1 to positive infinity is a decrease. So increase -infinity to 1, and then decrease was 1 to positive infinity. Like that. Alright, I spent a lot of time on that one little section. So, yeah. Let's go ahead and move on. Okay. Right here, evaluate the following piecewise functions for x equals -2, x equals 4, and x equals 6. Man, dude, I'm tripping. X equals 6, x equals 4. Alright, so we got to ask ourselves, let's start with this one right here, f of -2. Which condition does -2 fit? Is -2 less than 0, less than or equal to 0, or is -2 greater than 0? Well, we see that -2 is less than or equal to 0, guys. So we're going to solve using this equation. So what I do is I plug my x value, because again, this is x. You remember f of x Well, that's x inside the parentheses, so that's my x. So I plug it in. In doing so, I get -4. So f of 2 equals -4. Next, I'm going to do f of 6. And I ask myself, is 6 less than or equal to 0? Absolutely not. 6 is not less than 0. Is 6 greater than 0? It is. So I'm going to use this function to evaluate this. So I go 6 minus 2 is 4. Next, we're going to evaluate for f of 4. And again, is 4 less than or equal to 0? It is not. Well, is 4 greater than 0? Absolutely. So I go x minus, or not x, because x is 4. We just said that. So 4 minus 2 equals 2. So f of 4 equals 2. Now, I come over here for this one. Alright. For this one, we're using the same x values. Alright, these three up here. So first I start with f of 2, -2, excuse me. And I ask myself, is -2 less than or equal to 1? It is, so I'm going to use it for this equation right here. So that's x, and that's x squared. So we're going to go -2 minus a -2 squared, because that says x squared. Anyway, -2 squared is 4. So I get -2 minus 4, because of that minus right there. And -2 minus 4 is going to be -6. So f of negative, well, k in this case is k. So k of -2 equals -6. Alright. Now, we do k of 6. Alright. And you got to ask yourself, where does 6 fall? Well, looking at it, I see that 6 is greater than or equal to 4. So I plug it into this one. So that's -6, because it's negative right here, minus 8. And that gives me -14. So k of 6 gives us -14. Next, we have k of 4. And alright, we go, is 4 less than it's 4 less than 1? It is not. Is 4 between 1 and 2? It is not. Is 4 between 2 and 4? It is not. Because look, this is less than 4. So 4 is not less than 4. Right here, it says it's 4 greater than or equal to 4. And it is. It's greater than or equal to 4. So we're going to plug it in right there. So you have -4 minus 8. And that gives us -12. So k of 4 equals -12. All right, and then last problem right here from this section. We're going to use all the same x values. So we're going to go g of -2. And -2 is less than or equal to 1. So we plug it into this one right here. So we have -2 minus 1 squared. Well, that's -3. And -3 squared is 9. So g of -2 equals 9. Then we're going to do g of 6. And 6 is greater than 1. Fits this condition. So we go 6 plus 1. It's man, 6 plus 1 equals 7. I am so tired, I messed that up. And lastly, we have g of 4. Alright, and g of 4 is greater than 1. So we're going to do 4 plus 1, which equals 5 right there. Alright. Alright. Now let's see what we got here. Coming back over to number 7, graph the piecewise function. Alright, so we're graphing the piecewise function. Here's what we got. We have the conditions. We have our y values, our functions. So guys, I treat this like those are x's and the functions are y's, okay? So for right here, oh, the thing to remember how if it is equal to, greater than or equal to, less than or equal to, you have closed circles. Alright, but if it's just less than or greater than, they're open circles at the point. So right here, this says the graph is defined at 4. The function equals 4 between -3 and 4. Well, at -3, it is greater than or equal to. So it's a closed circle. Oh, wrong value. It says 4. So there we go. Move up one more. All right. And then right here, 4 is just less than 4. So I go over to 4. It's an open circle. And there we go right there. For -1, it is defined between 4 and 6. So 4 is a closed circle because it's equal at -1, -1. And 6 is an open circle. And then lastly, we have the function is defined as 6 between 6 and it's equal to and 10, which is not equal to, so it's just less than. So there we go. Right there. Alright. Now, let's go to the back. How much is on the back? Let's see. Alright, yep. I'm going to stop right here, man. This video's at 20 minutes. I'll make a part 2 real quick, and then I'll post that. Catch you later.